Hi, it's Mrs. Pope, and today we're going to talk about part 3 of writing linear equations. Our goal is to write equations of parallel and perpendicular lines. So, of course, parallel lines, or two lines, as you see my diagram, they are parallel. They have the same slope. So keep in mind, parallel lines have the same slope. It may look something like this. Y is equal to 2x plus 7, y is equal to 2x minus 13. They're two different lines, but their slopes are the same. So if you see that their slopes are the same, you automatically know that they're parallel lines. If you think about how it's sloping, if two things are tilted exactly the same, it doesn't matter where they are, they're going to be parallel to each other. So the other one we're going to talk about are perpendicular lines. So perpendicular lines, when they cross, they form a 90-degree angle. So the slopes of these are opposite reciprocals. Hold on. Opposite reciprocals. So the signs are different. If one is positive, the other will be negative. Reciprocal means you flip it. If it's a fraction, you flip it. So I say flip and negate. That's another way you can remember. So if one of your lines was 2/3 x minus 10, the slope of the other one would be opposite, so it would be negative. And it's not going to be 2/3 anymore. It's going to flip the reciprocal and be 3/2. So if you saw these two lines without even having them graphed, you can automatically tell that these are perpendicular lines because their slopes are opposite reciprocals. All right, so we want to write equations of the line that goes through 5, -6, and is perpendicular, to -3/2 x plus 7. So we've learned two strategies so far, and we're going to look at both of them to solve. So we have point-slope form, which we just had y minus y1 is equal to m times x minus x1. And of course, slope-intercept form, y equals mx plus b. So let's look at these and solve them both ways, or write the equations in both terms. Here we have x1, we need an x1, we need a y1, we need an m. Well, we have x1 would be 5, y1 would be -6, and if this is, we're writing an equation for a line that is perpendicular to this line. The only reason we have this line is to figure out what the slope of our line is. This line doesn't really matter, except for it tells us what the slope is. If our line is perpendicular to this line, that means our line is going to be the opposite reciprocal. So it's not going to be negative, it's going to be positive, and it's not going to be 3/2, it's going to be 2/3. So if we were to write this out, we have y minus -6, which will be y plus 6, is equal to 2/3 times x minus 5. That would be written in point-slope form. You can solve that out yourself and continue on to make it in slope-intercept form. And then you can just check your work with what we're going to do over here. So what if you didn't want to use point-slope or forgot point-slope or just want to try it both ways? Here we can use y equals mx plus b, and we can still find it and write it in slope-intercept form. So with this form, remember we need a slope and a y-intercept. Well, let's see. What do we have? We have a slope because we know it's the opposite reciprocal. But we don't have a y-intercept. But what we do have are x and y. So we could write out our y is -6, y equals m, where's x times 5 plus b. So we could simplify, and we would have -6 is equal to 10/3 plus b. So you can keep it at 10/3. You can turn it into a fraction, to a decimal, whatever you like. But let's just solve for b. So we're going to need to subtract 10/3 from both sides. So we have -6 minus 10/3 is equal to 10/3 minus 10/3 plus b. These cancel each other out. If you end up with a decimal, you would have -9.33, or if you did fraction, you'd have 28/3. Doesn't matter, either way. I'm going to write it as a decimal, -9.3 repeating. So our equation would be 2/3 x minus 9.3 repeating. So you could try, if you tried this indeed and solved it all the way down, you should have ended up with the same thing here. All right. Last example. Write the equation for a line that passes through 3, 7 and is parallel to y equals 3/4 x minus 5. Well, I'm going to use slope-intercept form. You can use point-slope. It doesn't matter. I want you to verify with point-slope, or maybe you like point-slope. Try that yourself. Doesn't matter. I'm going to use y equals mx plus b, and I'm going to plug in what I have. So I need an m and I need a b. I have an m. If it's parallel, that means the slope is going to be exactly the same. So my slope is going to be 3/4. I don't know b, but look what I do have, x and y. So let's plug it in and solve for b. 7 is equal to 3/4 times x, which is 3, plus b. We don't know b, and that's what we're trying to find. So 7 is equal to 9/4 plus b. We're going to subtract 9/4 from both sides. Again, you can keep it as a fraction, or you can turn it into a decimal. Doesn't matter to me. I think I'll go for decimal. So 9/4, 7 minus 9/4 would be 4.75. Cancel, cancel. 4.75 is equal to b. So b is 4.75. So my equation would be 3/4 x plus 4.75. All right, verify that with point-slope form. If you do it in point-slope form and simplify it out, you should end up with the same answer. Thanks for watching.